And now it's time for a quick digression. From my experience and the way I work, in every lighting project there comes a point when the basic light scheme is pretty much nailed for the most part, and you know it's good, and you are satisfied with it. Everything works together just fine. From there, it makes sense to change the perspective and give some love to materials before getting down to the lighting details. Materials in computer graphics dictate the way the light rays bounce off or travel through surfaces, and the influence of shaders on the overall look cannot be overestimated, so in this off-topic subplot, I guess we can try enhancing our materials with the subsurface light transport effect, and spend a few minutes casually talking about material properties in general. So we have strategically placed our key light behind the subject. Now what if we allowed some part of this light to actually penetrate the translucent surface of this object and exit at some different point? I'm talking about the subsurface scattering effect, or subsurface light transport as it's called sometimes. As we have mentioned already, by default this effect was disabled in our demo scene. What we can do now is strike it back on by reconnecting the loose dot that you can find in the shader editor back into the subsurface scattering slot. Doing that will open the way for some really intriguing lighting calculations. What we need to do is select our main mineral and open the shader editor in the top window. You can press Shift F3 if you want to do it via shortcut. There you will find our principal BSDF shader with a subsurface socket and the loose dot that needs to be dragged onto this socket. Subsurface scattering simulates semi-translucent objects in which light rays enter, bounce around, then exit in a different place. Aside from the subsurface slider that controls the amount of the effect, there is the subsurface radius drop-down menu where you can control the coloring or the tint of the effect. There are 3 channels there, red, green and blue, and you can tweak each one separately. For example, you can tweak the red one to increase or decrease the amount of red light scattered around. So yeah, basically that's how you give this mineral a sapphire, ruby or whatever else tint. Aside from the subsurface radius, there is one more parameter that allows us to tint the subsurface scattering effect, which is subsurface color, but I find it slightly hard to achieve really saturated colors. It's a little bit unpredictable, so that's why I resorted to use the subsurface radius instead. Now let's quickly explore the nodes that would go into the subsurface slot. I'm gonna Control Shift to preview this node alone. And basically there is the color ramp that receives the original diffuse texture, then makes it black and white and adjusts the contrast of it. The brighter the color, the more scattering and vice versa. Now Control Shift back onto the principled BSDF. Okay, so it's a mechanism of tweaking the variable subsurface scattering. Then we should just grab the loose dot and hook it up into the subsurface input, and we should be good to go. The contrast can be tweaked by moving the flags closer to each other within the color ramp node, and the power of the effect can be tweaked by adjusting the tone or the value of these flags. For example, by making it darker, you will reduce the amount of scattering. So, one mineral done, a few more to go. I will go through every object one by one really quickly, except the table. So let's select this stone in the background, click on the dot and connect it to the subsurface input. Now do the same with this one, and the one in the foreground has no subsurface scattering, so no need to touch it. Here's how it looked before, and after subsurface scattering applied. Once again, the position of our main light complements the subsurface scattering effect so much, because not only the shadows fall in the direction of the camera, and the reflections go in that direction as well, but the light scattered through the stone also exits in the direction of the camera, if that makes sense. And it all clicks because of the position of the key light in the reverse key manner. Cool, right? Now, while we are reviewing our materials, let's go through other properties of our principled BSDF shader, just in case. What else do we have here that can be controlled? We have the specular slider that controls the amount of reflections. That can play a major role in how the object would look under certain lighting conditions. How many glossy rays in cycles does it reflect? That could be important. And the other really crucial thing is how glossy is it? Or how diffuse is it on the other end of the spectrum? We have yet another color ramp here for controlling the glossiness or roughness, which is the same thing but inverted. You can play with the position of the flags to make the certain portions of the object look wet, for example. Let's disconnect this texture from the roughness input for a second. So basically, the low roughness means that the object is super glossy, surprise, and the higher roughness brings it closer to the perfect diffuse look. With the color ramp implemented, we achieve a so-called variable roughness, meaning that the certain portions of the object reflect the light in a more glossy manner, while the other are way more dull. The details like that may not seem like a big deal, but what is lighting in 3D if it's not interactions between the emissive surfaces and the materials, basically? So here comes the variable roughness color ramp. Ctrl-Shift to preview. Dark means glossy or even mirror-like if it's black. Bright means rough and diffuse. And then control the contrast via the flags within the color ramp. Okay, shift-click on the main material. What else do we have here? The object can be metallic if the metallic slider is pushed all the way to the right. Or it can be a perfect dielectric material if the slider is set to 0. Lastly, if you feel like turning this object into a diamond, feel free to experiment with the transmission slider that controls the object translucency, how much light passes through the object. It works similar to subsurface scattering, but in a slightly different manner. It doesn't necessarily scatter the light around, it lets the light pass through, just like glass. As they say, not everything is made of clay, and transmission shows just that. The transmission roughness controls how clear is the object transparency. At the higher values, it can make the interior or volume portion of the mesh seem murky. So that's what it does. Aside from that, there is a good old albedo texture or a diffuse texture at play that adds the base color to the object. Ctrl-Shift-Click to preview it really quickly. Yeah, there is the base color of the object that affects, among the other things, how much light bounces off that object. So there was a quick rundown of the properties of the mineral shader, principled BSDF, that can be tweaked alongside the subsurface scattering. I tried to keep the material fairly generic and fairly well balanced for the tutorial though. It has a little bit of everything. It's neither super glossy nor super rough. It has some subsurface scattering, it has some color, but not overwhelming amount of saturation in it. So that was a quick digression to bring the material and lighting interaction to the foreground for a second. That is important for 3D lighting. Now with that in mind, and with the added beauty of subsurface scattering, letting some light bounce around the object, let us return to our cinematic lighting setup and keep upgrading it.